So yesterday we went through this and some of us got a little bit farther than this, but I want to make sure we're all on the same page about what you should have drawn on the front page. So in class today, if you need to finish this, great. You can listen to this video and I'll walk you through the rest of it. Fabulous. If you are done, then move on to the next activity. So you should have these graphed from yesterday, right? We pressed on that Desmos link. It opened up. You saw all the different functions and you were able to draw the negative version of them when we plugged in a negative x. And later, we're going to kind of look at what that means graphically. But first, we're going to look algebraically. And so I know we touched on this yesterday. I'm going to zoom in so we can see a little bit better. But I do want to reiterate what we did, because I know some of us were listening and some of us weren't listening. And I know some of us need a little bit more help. So we're going to go through this. So we established that when this column matches this column, it's even. Because when we plug in a negative x and we get our initial function out, we know it's even. It's symmetric around the y-axis. I've already done the hard work for you of plugging in the negative x. So all you have to do is kind of fill in these as we go. So I'm going to fill them in first, and then I will fill in whether or not they're even or odd, and we'll talk about what that looks like. So I am multiplying each one of these initial functions in this column by -1, and that's how I'm getting this column right here. So if I have the square root of x, I multiply by -1, and I get the negative square root of x. If I have 1 over x, I multiply by -1 and I end up with -1 over x. If I am multiplying 2 to the x by -1, I end up with -2x. The absolute value, remember, an absolute value turns everything positive. But if we're multiplying by a -1 on the outside, it really doesn't affect the inside of what it's turning positive. I have this x to the third minus 2x. So I'm going to put a negative x to the third minus 2x. And if you remember way back when you learned about distribution, we have to multiply out that negative sign. And we end up with negative x to the third plus 2x. And then if you remember way back when you did right triangle trigonometry, sine, cosine, and tangent, sine is actually a function. And fun fact, sine looks like this function right here. So you've already kind of looked at it a little bit. We don't really know what it means yet. We're going to use it a lot to model real world things and a little bit longer in this math class. But right now we're just going to look at it as sine. And I want to make sure we all know it's sine and not sin. That will drive me crazy. So it's sine. And we're multiplying sine by a -1 out in front. And then we have our logarithmic function. And so when we look at this, we multiply it by a -1 out in front. And now we're going to go through and we're going to figure out, is it even or is it odd? So I have a square root of a negative x, and a negative square root of x. None of these match. So because none of these match, it's neither. Now our next one, the hyperbola, we have 1 over x, 1 over negative x, and then -1 over x. These two look the same. So if these two columns look the same, if when I plug in a negative x equals negative of my initial function, I end up with an odd function. So this is odd. If I look at the next one, 2 to the x, 2 to the negative x, and -2x are all different. So these are neither. the absolute value. As I mentioned before, an absolute value turns everything inside of it positive. We should know that. So this and that match. So an absolute value function, like you saw on the first page, is even. If I look at this next one, it looks like when I plug in a negative x and when I multiply by a negative, I end up with the same. So these have to be odd. And something that I forgot about in one of my classes, we got this far, and I think I kind of messed this up and I said this was neither. So I want to double back on that. So for our sine function, we'll learn when we go back to trigonometry that this and this are equal. So when we have a negative x in the sine function, it's the same as writing negative sine x. My bad. So I know I told you that this one was neither, but it's actually odd. And we can see that in this graph, because if we were going to rotate this blue one by 180 degrees around the origin, we'd end up with the red one. So just to reiterate, in case that didn't pop up on my screen, if we go back to this first page, we know that sine is odd because if we rotate that blue graph 180 degrees, we end up with the red graph. And then last but not least, we have our logarithmic function, and our logarithmic function is neither. So at this point, we should know that a function is even because the graph mirrors itself across the y-axis, which is in your notes. You already have this written from yesterday. And we should know that a graph is odd because it is rotated by 180 degrees around the origin. So we should be able to have this all filled out on our paper, no problem. Now, the next thing we're going to do is you are going to determine if a function is even or odd by looking at its graph. And so you can graph them on Desmos, but at this point, you probably should be able to figure out that this is a parabola centered at the origin. And we know based off of this graph that it's even because it uses the y-axis as a mirror. And by now, we should know that when we have a +5 inside our parentheses, that's telling us that we move to the left by 5. We know this vertex form. So if we go here, we'll call this 5. And although this parabola is also a parabola, it's not centered around the y-axis. So if it's not centered around the y-axis, this has to be neither. And you could see that if you wanted to plug in a negative x as well. On Desmos. So you could plug in this to see what you get out. So you are going to do the next 4 of these. I think you've got it. And then from there, you're going to do a couple more problems on the slide where you just came from to find this video. And then you should be done with class.